So we've covered what charges on the periodic table you should know. So as a reminder, this first column, or the alkali metals, are a +1. Alkaline earth metals are +2. We have silver, zinc, cadmium, aluminum, and gallium that you should know. Silver was a +1. Zinc and cadmium are +2s, and aluminum and gallium are +3. The noble gases don't have a charge. The halogens are -1. Then we have -2, -3, and -4. And that's only going for the nonmetals of those groups. So technically those two are -4, and then we don't know, -3, -2, and so on. Positive ions, or cations, have more protons than they do electrons. Therefore, they're going to lose electrons. And metals always lose electrons, so metals are going to be our cations. Negative ions, or anions, gained electrons, and therefore they have more electrons than protons. This results in it having a negative charge, and this is going to be our nonmetals. Most metals have more than one charge, and therefore when we name them, we have to indicate the charge that we are using, like we've said before. So all metals except group 1A, 2A, silver, zinc, cadmium, aluminum, and gallium have more than one charge, and therefore need Roman numerals when we name them. So calcium, looking on the periodic table, figure out what the charge of calcium is. You said +2, you are correct. Oxygen is a nonmetal, so you should see that one on the right. And oxygen always makes a -2 charge. And remember from previous units, we've said that when you see Roman numerals, that's indicating the charge of the metal. And because it's a metal, it should be positive. So nickel 3 is simply nickel with a +3 charge. Go ahead and pause the video and answer these other 6 on your own. Restart when you have those 6 charges. So silver was a +1. Nitrogen, a -3. Aluminum should have been a +3. Lead in this case is a +2. Zinc is a +2, and bromine is a -1. If you missed any of those, go back to the periodic table and re-find it, and make sure that you're looking in the right column and finding the correct element. So this video is working on writing ionic formulas. So an ionic compound starts with a metal or ammonium. Remember that ammonium was our only positive polyatomic ion, which is NH4 + 1. When ions combine together to form compounds, the overall charge of the compound that results must be 0 or neutral. So we're trying to get them to cancel out. And the metal ion is always written first. So to do this, first we're going to write the symbol and charges for each of them. So we got K has a +1 charge, and Cl has a -1 charge. Well, a +1 and a -1, if I just have one of each of them, they're going to cancel and give me 0. So the formula when those go together is just KCl. For the next one, magnesium, we look on the periodic table and find its charge is a +2, and chlorine is still a -1. Those do not add up to 0 if I just had one of each of them. So I need to figure out what the lowest common multiple is and say, well, I would need 2 chlorines to cancel out 1 magnesium. So I get MgCl2. Another way I could have thought about it was crossing the charges. That 1 goes over here minus the negative sign, And that 2 goes over here minus the plus sign. I just don't write the 1 and I only write the 2. So then I get MgCl2. To check myself, I can say 1 times 2 is negative 2, 2 times 1 is positive 2, and notice those add up to 0. Let's look at the next one. Iron is an Fe, and in this case is a plus 3 charge. Oxygen has a negative 2 charge from the periodic table. So again, those are not canceling out. I could multiply them together and get 6 and say, oh, well, I need 2 irons to get to 6. And I need 3 oxygens to get to 6. So 2 times 3 is negative 6. 3 times 2 is positive 6. Notice they add up to 0. Or I could do what we did a second ago and cross the charges. That 2 goes here. That 3 goes over here. Notice I'm just crossing them. If crossing them, though, you do have to be careful that if they reduce, you reduce them down. So reducing would be if they're the same number or a 2,4, a 2,6, things like that. Polyatomic ions are ions which are made up of several different elements. These elements have to stay together in chemical reactions. If you must add subscripts, you're going to add them after the polyatomic ion, and it must be placed in parentheses first and then the subscript added outside the parentheses. And like we said a second ago, ammonium is the only positive polyatomic ion. These polyatomic ions are located at the bottom of your periodic table that I gave you. They're also on that separate sheet. When you look at your polyatomic ions, these have -1 charges, with the exception of ammonium, and then -2 charges, and then -3. So we'll see that the majority of our ions have a -1 charge. So we're going to do it just like we did a second ago. Zinc has a +2 charge, because we know zinc's charge is always a +2. Sulfate, if it ends in ATE or ITE, notice our polyatomic ions end in ATE and ITE the majority of the time. So I say, oh, sulfate is this one. So that's SO4 with a -2 charge. Well, a 2 and a 2 add up to 0, so I don't need to cross anything. I don't have to find any lowest common multiples. I just need one of each of them. That 4 came from sulfate, not from me saying I need 4 oxygens. So I have 1 zinc and 1 sulfate. For this next one, gold is Au. And gold has a variable charge. That's why they gave me the charge in Roman numerals. Nitrate, again, ends in ATE, so I look on here. Up there's nitrate. So it's NO3, -1. In this case, these do not add up to 0. I need one more nitrate to cancel out that gold. So Au, NO3, 2. I have to put my polyatomic ion in parentheses. I don't change the oxygen to a 6. I don't distribute it. I just leave it as NO3 with parentheses 2. Notice 1 times 2 is -2, and 2 times 1 is +2, so those added up to 0. So on these, we're writing the correct formula. Let's go ahead and look at 2 more, and then I'll let you practice on your own, and then we'll check them. So lithium, make sure that you're writing the symbol and the charge. So lithium is Li with a plus. Then fluoride, if it ends in IDE, it's going to be an element. The 2 exceptions to that are hydroxide and cyanide. All of your other polyatomic ions end in ATE or ITE. So fluoride, I look on the periodic table, is fluorine with a -1 charge. So a +1 and a -1 should cancel, giving me LiF. My next one, calcium, is Ca with a +2. Sulfite, I look on the periodic table at the bottom, and sulfite was next to sulfate. It's SO3 with a -2. When it ends in ATE, it has more oxygens, ITE, less oxygens. So that's SO3 with a -2 charge. Again, those cancel when they add up to 0, so I just need 1 calcium and 1 sulfite. Go ahead and pause the video and do copper 1 oxide on your own. So copper is a +1 because it told it to us right there. Oxide is oxygen with a -2 charge. And in this case, I need 2 +1s to cancel out a -2. So Cu2O. Again, if I was crossing those charges, that 2 would go here, and that 1 would go here. So Cu2O1, and I leave off the 1. Go ahead and pause the video and do these 3 on your own. Restart when you have your answer. Aluminum is +3. Bromate is BrO3 with a -1. We get that right here. So I need 3 bromates to cancel out aluminum. So I can't leave it like that because that's 1 aluminum and 1 bromate. I've got to put bromate in parentheses and a 3 on the outside. Tin, you should have said was SN, and that's a 4. Sulfide is just S with a -2 charge. So the most common wrong answer for this one is this, when people cross the charges and don't reduce. So that reduces to SnS2. The other way of thinking about it, I need 2 -2s to cancel out with a +4. So if I need 2 -2s, then I have a 2 on the outside. But if you're crossing them, you do have to be very careful of that 2 and 4 that they reduce down. Ammonium was our positive polyatomic ion. And then phosphide is the element P with a -3 charge. So in this case, I need 3 ammoniums and 1 phosphorus. Go ahead and pause the video and do these 3 on your own. Restart when you have your answer. So sodium is a +1. Hydroxide ends in IDE. But remember, it was one of our ones that's a polyatomic ion that ends in IDE. So that was OH with a -1. +1 -1 should have canceled. So just NaOH. Gallium is Ga, and it's one of the elements that you should know the charge of. Bromide is Br with a -1. So we need 3 bromine to cancel out that gallium. So GaBr3. Barium was +2. Phosphate is PO4 with a -3 charge. So BaPO4. We need a 2 and a 3, so that's a 3. And then PO4 with a 2. 2 times 3 is 6. 3 times 2 is 6. That's barium phosphate. Make sure when you're typing these answers, if you type them that B is capitalized, the A is lowercase, then you have your 3, parentheses, capital P, capital O, 4, close parentheses, 2. Make sure that you're capitalizing what needs to be capitalized and lowercase the second letter of element. So gallium bromide, capital G, lowercase a, capital B, lowercase r, and then a 3. Go ahead and pause the video and do these 3. So cobalt is a capital C, lowercase o. Make sure that that's definitely a lowercase o, not capital. And it's a +2. Hydroxide, we've seen before, is a polyatomic ion. So in this case, I need 1 cobalt and 2 hydroxides. That's the most common wrong answer. Make sure that you're putting parentheses around hydroxide. Even though it doesn't have any subscripts on it, it's a polyatomic ion. And so if you wrote this, that's 1 cobalt, 1 oxygen, 2 hydrogens. We want 1 cobalt, 2 oxygens, and 2 hydrogens, or 2 hydroxides. K is silver. Silver was a +1. Nitrate is NO3 with a -1. Those cancel, so we just get AgNO3. Zinc is Zn with a +2. Acetate ends in ATE. It's from our chart. So that's C2H3O2 -1. We need 2 acetates for every 1 zinc. So we have to put acetate in parentheses with a 2 on the outside. All right, last set. Go ahead and pause the video and solve these 3 on your own. Resolve when you've got your answers. So lithium is Li with a +. Nitride is nitrogen with a -3 charge. So we need 3 lithium to cancel out 1 nitrogen. Or again, if I'm crossing, that 3 goes here, that 1 goes here, and I do not write that. Remember, when crossing, you should not have any charges because the bottom tells me how many, the top is the charges. Potassium was K with a +1. Chromate is CrO4, -2. And so I need 2 potassium to cancel out my 1 chromate. So K2CrO4. Last one, cadmium is a +2. And sulfate is SO4, -2. Those cancel. So CdSO4.